Hello and welcome back to Data Analysis and Visualization. I'm Javita Christie, and in this video, I'm going to talk to you about topology structures and spatial plots and maps. So let's begin. What are topology structures? Topology is the practice of using geometric structures to describe and model the relationships and connectedness between entities and variables in a dataset. So geometric structures would be something like trees, or they could be graphs, and you're going to see all of those now when I show you some pictures of those little bit later in the video. Now you need to understand basic topology structures so that you can accurately structure your visual display to match the fundamental underlying structure of the concepts you're representing. And so let's take a look at a list of topological structures that are popular in data science. So the first structure is linear topological structure, which is representing a pure one-to-one relationship. And they are often used in data visualizations that depict time series flow patterns. So if you want to show a process, this was the beginning, then this is the next stage and next stage, then you would use a linear topological structure. Any process that can only occur through a sequential series of dependent events is linear, and you can effectively represent it by using this underlying topological structure. And it looks something like this. So it's a linear relationship and it is a one-to-one relationship. So that means one of these bubbles or circles that you see can be connected with only one other bubble or circle, which is why it is linear. And then at the same time, it is also sequential. So if you had a process where you had to do one task and then the next and then the next, but those tasks were supposed to be sequential, which means only when you do task one, only when you finish task one, you can do two. So that is a linear relationship, and that's what you can depict using topological structures. Then we have graph models. These kinds of models underlie group communication networks and traffic flow patterns. You can use graph topology to represent many-to-many relationships like those that form the basis of social media platforms. The social media platforms are an example of many-to-many relationship where you have you have a friend on Facebook, and that friend also has many friends on Facebook. You have many friends on Facebook, so it's a many-to-many relationship type of structure. And to show that type of a structure, you would use a graph model. You would also use it to show communication networks where one router is connected with another one, to show even traffic patterns, traffic flow patterns, where how data moves around through the network. A many-to-many relationship is a relationship structure where each variable or entity has more than one link to the other variables or entities in that same data set. So let's take a look at a picture of that. This is a graph model. You can see there are six circles or bubbles, and they are practically connected with everything. So one is connected with everything else. And that's why it's a graph model, because it's a many-to-many relationship. The next topology we'll talk about is the tree network topology. This topology represents a hierarchical classification where a network is distributed in a top-down order. Nodes act as receivers and distributors of connections, and lines represent the connections between nodes. End nodes act only as receivers and not as distributors. So this is a hierarchical distribution or classification where there's a network that starts with a single node that transmits data further down, and then those nodes pick up the data and transmit it even further down. And so every node acts as either a receiver or a distributor or both. So the root node would be the one that's acting only as a distributor, and then the bottom leaf nodes are all receivers and not distributors. Hierarchical classification underlies clustering and machine learning methodologies in data science. Tree network structures can represent one-to-many relationships, such as the ones that underlie a family tree or a taxonomy structure. So when you have a family tree where you have your parents and grandparents and their grandparents, so you have all those that type of a tree structure, then that's the kind of structure that would show hierarchy. Or even in an office where you have managers handling certain employees, you could create this type of a structure there as well. So if you have that type of a structure, you could very well use tree network topology to show it as a visualization. And hierarchical classification also is used in clustering and machine learning, which are two methodologies in data science. And this is what it looks like. So you can see there is a root node on top, which is then spreading out and creating other nodes. So it is a sort of a data transmission from root to other nodes. And these bottom ones are known as leaf nodes. So you cannot transmit any data beyond that. So that's a tree network topology. Now we're going to look at spatial plots and maps. Spatial plots and maps are two different ways of visualizing spatial data. A map is just a plain figure that represents the location, shape, and size of features on the face of the Earth. So as the name suggests, spatial plots and maps are used mainly to show the location, size, and shape of different areas on the Earth. Spatial plots are visually more complex than maps. They show the values for and location distribution of a spatial feature's attributes. And here we are going to see a list of spatial plots and maps that are commonly used in data visualization. So the first one is a chloroplast. Despite the fancy name, a chloroplast map is really just spatial data plotted out according to area boundary polygons rather than by point, line, or raster coverage. So instead of using a point, line, or raster coverage, you want to create a polygon. So you want to create a shape, a polygonal shape, and show the area in that way. So this is what it looks like. You can see there are lots of polygons created right here in this region where you have pink and blue and yellow. So you can see it's more of a squarish shape rather than just, drawing a line and creating anything. We're trying to create a polygon. So that's a chloroplast. It's very simple to see and understand. In this map, each state boundary, as we saw in the previous map, represents an area boundary polygon. The color and shade of the area within each boundary represents the relative value of the attribute for that shape, for that state, where red areas have a higher attribute value and blue areas have a smaller attribute values. So there is also an attribute value associated with each color of the polygon that we saw earlier. There was pink and some of it was yellow. So you could show different attributes by coloring those polygons differently. Next, we have point maps. Comprised of spatial data plotted out according to specific point locations, point maps present data in a graphical point form rather than in polygon, line, or raster surface formats. So instead of showing it as a polygon or a line or a raster surface format, point maps are plotted out according to special or specific point locations. And let's have a look at how it looks. This is how it looks. It is again a map. As you can see, it's a region 3 map of some region, and it's about active wells, active decreed wells, and it is just shown, all the things are shown as points on the map. So that's a point map. It's very simple. Just like a chloroplast, this is also quite simple to understand. And then we have raster surface maps. These spatial maps can be anything from a satellite image map to a surface coverage with values that have been interpolated from underlying spatial data points. So whatever you see in a satellite image, that's an example of a raster surface map. And it looks something like this. So this is how a raster surface map looks. There are different, it's a sort of a mixture of chloroplast and point map, because there are points, but as well as there are those colored regions that are separated out based on some characteristics, maybe heat signature or something. So um, that is a raster surface map. Now we come to a conclusion of this whole topic about, what kinds of data graphics are available and what kind should you choose. So that's where we are at now. You've already seen a list of a whole bunch of data graphics in this video as well as in the previous two videos. And so now you know that these are the options available, but you need to decide which one best suits your needs. And so that's what we are going to discuss here, choosing your data graphic. The first step is scope out the questions. Ask yourself the questions that your data visualization should answer. Then look at your visualization and determine whether the answers to those questions jump right out at you. So if you're trying to show increase in sales, then ask yourself a question, is there an increase in sales or is there a decrease in sales? And then just look at your data visualization. And when you look at it at first glance, are you able to tell whether there's an increase or decrease in sale? If that's the case, then you've chosen the correct graphic. Next, you should take users and media into account. Consider who will consume your data visualization and using which medium. Do your data graphics make sense in that context? Because sometimes when you want to show a data graphic, and if you are going to use people are going to use a medium like a mobile phone, and your data graphic is just too tiny and does not have enough information that's visible without zooming, then it might actually defeat the purpose of having that graphic. So you might want to use something simpler and something that can be shown in a large picture on a mobile phone. And then the third step is to take a final step back. Look over your data visualization to ensure its message is clearly conveyed through the data graphic alone. So people should not have to go through any extra information to understand what you're trying to say. Just the graphic itself should be able to convey the message that you're trying to convey. Now let's take a little bit, let's dig a little bit deeper into those three steps. So first we talked about scoping the questions. Before thinking about what graphics to use, first consider the questions you want to answer for your audience. In a marketing setting, your audience may want to know why their overall conversion rates are low. So first you need to understand what kinds of questions you want your data graphic to answer, as we talked about earlier. And there's an example given that if you have a marketing setting, then your audience might have a very simple question about, why their conversion rates are low, why they are able to get people to their web page or their mobile application, but they are not able to convert those people into customers because they are not buying anything. So why is that happening? And does your data graphic answer those questions? If you're designing for business managers, they may want to know why service times are slower in certain customer service areas than in others. And many graphic types can fulfill the same purpose, but whatever you choose, step back and check that your choices clearly answer the exact and intended questions. So there are many ways to show the same thing, but you want the way that you pick to be the best one for showing that type of visualization and for answering those kinds of questions. Now, taking users and media into account, which was the second step, consider where your data visualization will be used. Will an audience of scientists consume it, or will you use it for content marketing or to generate internet traffic? Do you want to use it to prove a point in a boardroom? So these are some of the questions that you might want to ask yourself about where exactly your data will be used by either scientists for marketing or in a boardroom. Do you want to support a story or an upcoming in an upcoming newspaper publication? So these are all these questions, and based on that, you should pick a graphic type that is most appropriate for the intended consumers and for the medium through which they'll consume the visualization. And the final step is to take a step back. So finally, to ensure that you've chosen the best graphic form, take a step back from your data visualization and evaluate whether the graphics you've used make sense. Because you need to ask yourself the same questions again. Is my graphic conveying the meaning that it is supposed to? Is it answering this question, or is it answering some other question? If viewers have to stretch their minds to make a visualization comparison of data trends, you probably need to use a different graphic type. So if users or viewers or consumers who are going to see your data visualization, if they have to work out a visual comparison of data trends from your graphic, then that's not a good graphic, because they have to stretch their mind and they have to think for themselves when your graphic should just be doing all the work. So this is where you have to take a step back and answer the questions that you found out in the beginning. If viewers have to read numbers or annotations to get the gist of what's happening, it's not good enough. Test other graphic forms to see whether you can convey the visual message more effectively. And with this, I'm going to end this video. I hope you understood all types of graphics that I explained here and how to pick the one that most suits your purpose. I'll be back with the next video, so I'll see you there, and thank you for watching.